All right, we are recording. All right. Hello, everyone. My name is Catherine Sommerfeld. I'm the Director of Marketing Campaigns and Events here at Flatiron School. Really excited to have you here, and I want to welcome you to Flatiron School's Tech in 20, Code and Data Literacy in the Information Age. Without further ado, I'll introduce our host for the evening, Mark Barbour. He is one of our lead data science instructors. Take it away, Mark.
Hello. I figured I'd start by first and foremost just thanking all of you for being here and welcoming you, and then just giving you a brief idea of my background and where I come from and how I got to Flatiron. So I started my career in information technology as a 911 dispatcher for Phoenix PD. I started really young. I was only 20, and I couldn't imagine how technology driven a job like that was before I worked there. Once you're a fully cross-trained dispatcher, you've got 7 monitors over 3 different computers, 3 different mice, 3 different keyboards, radio in one ear, a phone in the other ear, and a foot pedal to operate it all, and a mute switch. So you're just like really locked into technology, and I really enjoyed that side of it. So I got a couple of IT certs and started doing pretty much everything in IT. Worked primarily for Berkshire Hathaway, JP Morgan Chase. I've worked for some smaller regional title companies, things like that. And I was doing everything from network engineering and support to data center operations, project management, rolling out massive enterprise Wi-Fi systems, voice over IP systems. I've pretty much anything low voltage I've touched. And as I kind of developed in my career, I was just more and more fascinated by data. A lot of that came from 911, just seeing how powerful information can be, especially when it moves, very quickly and efficiently. It gave me a lot of hustle for IT, going from dealing with stuff that's like seconds and minutes matter to stuff that's like days, weeks, months, so I brought a lot of those skills with me. I got into data science almost kind of just by falling into it. I had a lot of connections in real estate, like managing brokers and stuff like that when I was working with Berkshire Hathaway. And, people in real estate have a lot of data, and kind of got into data analysis from that perspective, and did a lot of kind of side consulting. And the great thing about real estate people is they know everyone from every industry. So as I developed some contacts in real estate and started doing more and more data science consulting in my business. I just kind of ended up working in all kinds of different places. I've done everything from real-time search and alert for facial recognition, weapons detection, fire detection. So like the kind of AI security implementation side of things. I've done photogrammetry, measuring clothes with cell phone cameras, modeling radio towers, classifying equipment inside of radio towers. Just kind of been in tons of different industries, banking, real estate. Done a lot of volunteering and kind of education and code and data literacy advocacy. That's kind of what I wanted to spend a little bit of time talking to you guys about tonight. And apologies, I'm a little slow on the chat, so if I miss anything, feel free to bug me again. And Catherine's also going to keep an eye on there as well. So if you guys have questions, feel free to chime those in. Let's see here. Oh, and actually I see Catherine had just put that in chat, so thank you. My goal tonight is basically just inspire more people to explore programming and statistics, kind of understanding code and data literacy. And I know those can seem like very dry and daunting, and sometimes, at times even intimidating. Even professionals, can get intimidated by this stuff all the time. So I want to inspire people to take a second look at this stuff, and just try to learn more about it. I think there's real impact, at pretty much every level. I mean, I routinely cite knowing how to program as one of the most valuable skills I took the time to develop, with a very second close to the communication skills I developed at 911. So, I know these topics can look a little intimidating and seem a little bit dry, but I think the important thing to remember is as technology changes, as things become more and more data driven, I mean, reading can be seen as a very dry and intimidating topic, but it's something that we all do, right? And we don't necessarily learn how to write and read to become authors. We do it so that we can, do finances, so we can pay our bills, so we can be citizens in a society and, get driver's licenses and passports, so we can work and kind of be functional in society. And reading has almost gotten to this point where it's something that we really take for granted. But it wasn't always like that, right? And so there's a couple of histories throughout, or a couple of examples throughout history that I want to draw parallels to. I want to talk a little bit about this predominant concept in the industry now called the fourth paradigm. And I'll kind of talk about the history through that lens. So when you take a concept like science, right, it's this process that allows us to kind of filter out what's actually happening in reality, right? We can have our observations, we can see things, but the more we study neurology, the more we try to understand things, especially looking at things like artificial intelligence and like, how do you make a robot that can, excuse me.
Bless you.
Pardon me. I'm glad I got to the mute button in time. I miss my mute switch from 911. Totally got distracted. Oh yeah, so we kind of rely on our senses and our observations, but the more we are learning, through neurology and studying artificially intelligent systems, robots and sensing systems, we're realizing that our senses are very, very easy to fool, right? And if you want a really good explanation of that, I highly recommend a book called Sleights of Mind by two neuroscience researchers from Barrows Neurological Institute in Arizona. And they basically went around and they interviewed a bunch of magicians, professional illusionists. And their premise was that it wasn't mathematicians that originally worked out the rules of perspective and geometry and all those kinds of things. It was the painters and the drawers and the artists and, Da Vinci's of the world. And then the mathematicians kind of came in later and figured it out. And so their hypothesis here was maybe there's a similar phenomenon going on with magic and illusion, right? And so as neuroscience researchers, they went and interviewed all these professional magicians, and they were very open with their magical secrets. And they realized that there's a huge overlap in that magicians' canvas is not paper or canvas, it's attention and cognition, right? And so, there's that inherent flaw of kind of just relying on your observational senses. And this is kind of the empirical paradigm of science, right? You kind of go out into the world, you observe things, and then you make up a narrative about it to try to explain it as best you can. But ideally, you have some predictive capacity or some forecasting capacity, right? It's one thing to be able to explain what's going on right now, but it's almost like a superpower to be able to explain what's going to happen in the future, right? And so you go back to the days of, say, Eratosthenes, right? This is kind of the first person in the historical record, maybe not necessarily the first person, but the first person that we have recorded history about being able to prove that the world is round, right? And the way that Eratosthenes did that, and this is like 300 BC, he used his senses. He noticed that if you look down a well at the equator, you could see the sunlight hitting the water all the way at the bottom. But if you were to go, a few hundred miles north or south, and you look down a well, the angle of the shadow from the sun just kind of doesn't quite reach the bottom, right? And so just by using his senses and kind of some geometric logic, he was able to conclude that the surface of the earth has to be round in some way, right? And the limitations of that are, you kind of go from Eratosthenes to Copernicus, and Copernicus figured out the arrangement of the celestial bodies, right? He kind of broke this narrative that Earth was in the center of the solar system and everything else in the universe revolved around it. He was able to kind of arrange things properly, but his flawed assumption was that everything moved around in perfect circles, right? And at the time, we had writing, we had literacy, but it wasn't prevalent enough that you could just cheaply record a bunch of data about how celestial bodies moved and then analyze that data and figure something deeper out, right? They just kind of looked up at the sky and said, hey, these things move this way. This is probably how it is. And then when, like Mercury or Mars are in retrograde and you have all these weird unexplained events because things don't actually move in perfect circles, it causes a lot of confusion and a lot of paradoxes that people will fight over and argue over, right? And so that's one of the limitations we have of relying on just the empirical paradigm of science, right? We have to get more than just our senses. And also we're limited by time. We only exist for so long. If you can't write things down, then you're kind of limited in how far that analysis can go. And that kind of brings me to one of the first well-defined instances of applied data science in history, which is with Kepler and Johannes Kepler and Tycho Brahe. And basically, these were two astronomers. Tycho Brahe was the one that kind of was set up with all the hardware. He had been very wealthy in his life, and he had a small little island that was really well situated for observing the stars. And he had built, this giant telescope, maybe not by today's standards, but certainly by his day's standards. And over years, he just very studiously recorded just immensely large amounts of data. Every night he'd go out and he'd record data and record data and record data. I think developed into this problem where you have so much information that now you hit this restriction of how much can you compute and how much can you interpret the results of that computation. And this is where Johannes Kepler came along. He was significantly younger than Tycho Brahe, and when Tycho died, he was able to get Kepler was able to get his hands on that data. And then he was then able to develop our not entirely accurate, but the foundational model of our universe, right? That yes, the sun is in the center, just like Copernicus figured out, but things don't move in perfect circles, right? They move in orbits. And that means they can have different speeds. That can change over time. But his key insight was that, the area that was swept out by a moving body is equal with equal time, right? So if you were to like clock a month of a planetary movement and clock another movement, another month of movement, regardless of how far away from the sun it is or how fast it's moving or whatever its angular velocity is, it didn't matter. If you measured the same amount of time, it was going to sweep out the same area, right? And that was his key insight that allowed us to all of a sudden resolve all these paradoxes from Copernicus's time. And the reason why this is significant for data science is primarily because it showed us a division in the data collection and then the analysis, right? The difference in curating and gathering and developing that data, and then the difference in computing what needs to be computed and going through and analyzing the results of that computation. And so we kind of go from this empirical paradigm where we can just rely on our senses, but we deal with all these strange paradoxes, to a more theoretical model where we can gather enough data to get a sample of what reality is doing, and maybe ideally have other people in other areas do that independently, kind of the traditional use of the scientific method, to the point where the scientific method generates so much information that we need computers to sort it out. And then not only do we need computers to sort it out, but we need some model for how information changes in larger and larger quantities, right? We call this concept emergence. So, my go-to example for this is if you spilled a gallon of water in your kitchen, you'd probably have the skills and resources to clean it up. If you accidentally knocked over a 5-gallon bucket of water in your kitchen, you probably could still clean it up, but it's very different than just a gallon, right? But then you keep that going and you realize that if you want to move like a pool's worth of water, you need special equipment, you need training, you need permits, you need, all kinds of other things. It's the same substance, but at a certain quantity, it just becomes different. It has similar properties, but has many, many more differences. And data is like this, right? Many of us, I know, at least I do, feel stressed out by the amount of information I have to deal with on my computer and my phone. And like, if I lost my phone, like how much of a hassle that would be because I don't have that information. This is why you should back up things and also encrypt them. So whoever does get a hold of your devices don't, steal your identity or anything like that. But we can all kind of reasonably manage the general day-to-day information about ourselves, maybe about our families and our social groups. But at a certain point, it starts to become overwhelming, right? And this is the key value of what the data scientist has to offer, is our ability to deal with extremely large amounts of data and information. And we're kind of getting close to time, so I want to leave you guys plenty of time for questions. But the key point I want to make here is there have been a lot of historical instances where literacy comes with a great amount of power, right? The US in World War I, they had all these recruits or conscripts. They showed up, they couldn't read a field manual. Like something like 40% of soldiers couldn't use a field manual due to illiteracy, right? And this kicked off this massive universal literacy campaign in the United States and kind of built a national standard for public schools. And largely we achieved universal literacy for reading and writing in the United States. And this solved a lot of problems in the industrial era, right? Look at the history of the industrial era. It's not pretty. But literacy didn't solve all of those problems, but most of them, right? But now the problem is we're knocking on the door of a brand new technological paradigm change where information, computation, and data are even more significant factors in how power is distributed throughout the culture. And we're at that point where that literacy is lacking, right? There might only be a few million people on this planet who are code and data literate. And most of those people run the world, right? You look at the Forbes billionaire list, that's slowly gone from industrial activities like the Waltons and distributing goods all over the world with trucking to tech billionaire after tech billionaire after tech billionaire after tech billionaire, right? And that can be concerning, right? If you get too few people that are hyper literate and too responsible for too many things are going to get unstable. And so I think the challenge in this next decade, especially and definitely for the rest of the century, is we need to induct more people into code and data literacy. We need more people who can understand computers, understand how to program and communicate with them, and be able to deal with extremely large amounts, and not just large amounts, but ever increasing amounts of data, to resolve a lot of the problems that are going to come with the information age, many of which we don't even know of yet. So I'm hoping this encourages many of you to go out and learn more about programming, learn more about things like statistics. These are very, very powerful and helpful things. I'll kind of open it up for questions.
So we had one comment early, which was, are you a data scientist primarily or a data analyst, and which one should be studied first?
I definitely started with data analysis, and I kind of break it down in three ways, right? You have your technical skills. This is your ability to kind of move your way around a computer, use a terminal, use version control and collaborative coding stuff, right? Just getting your hands on the data and the way it's stored and the tools that you use to do that, right? Then you have the academic skills. This is having a deep enough understanding of statistics, linear algebra, calculus, to have a solid intuition, more than just a guess, but like an educated guess about what systems are likely to do, right? This is built on top of the scientific method. So we still want to make a hypothesis about what things are doing, and we want to be informed and educated about that. And then you have the soft skills. How well can you communicate these complex things to other people? I'd say the data scientist has all three of those skills and would need all three of those skills and be quite strong in all of them. And the data analyst focuses more on the academic and the soft skills side of things, right? This is helping stakeholders interpret things like visualizations, make broad general understanding of the data, being able to develop a narrative. So you really want to have strong soft skills and academic skills because you're trying to share that knowledge with other people. The data engineering side is more the technical skills and the academic skills. And that's where, again, you're focusing more on things like data cleaning, acquiring data, managing it, making sure that it's secure and persistent, all that kind of stuff. I think depending on your personal experience, data engineering or data analysis is typically what you're going to start with. Usually you'll work with a data scientist who typically is a project manager for the data science lifecycle. So that's kind of, that's some of the stuff that I've done in my career. But I mean, in reality, I think the best place to start is just where you have your strengths, because that's where it's going to feel the least overwhelming, and kind of give you enough encouragement to keep going. But all three of those skills are something that I think, data professionals in general should have, just depending on the strengths and the ratio of that strengths, I guess would be kind of whether you're considered a data scientist.
Okay, we've got a couple more. One, I'm new to tech. Do you recommend I look into being a Scrum Master?
Yeah, Scrum, Agile, a lot of it's, a lot of it really is just about project management and communication. How can you take a really, really complicated project, like dealing with terabytes of data, or dealing with a very complicated backend of a website, or, any of that kind of stuff. I mean, even just building software. I think the Scrum stuff is definitely valuable. I'm not Scrum certified or anything like that. I haven't needed it in my career, but there's definitely points at which I wish I had it. It would probably make things a lot easier. And if you're in an environment that relies on that, things tend to be a lot more organized. So if project management or something like that is something that you're interested in, I'd encourage you to go for it.
And then we have any projects or resources you recommend people to start on to build a portfolio?
Absolutely. First and foremost, blogs. As you're learning, document that, write that down. A lot of the modern, kind of work environment, or at least kind of the headhunting environment, is what shows up when someone Googles you, and if you have articles that you've written, especially stuff, it can be a little uncomfortable because you don't know what you're doing. You don't necessarily know what you're writing, right? But one of the skills that's highly valued in this industry is, can you go from not knowing to knowing? And what does that process look like for you? How do you handle frustration? How do you handle failure and defeat, and dealing with the umpteenth error on the same line of code that you're trying, is there some kind of resilience there, right? So as you learn, document your learning, right? And you'll find a handful of tutorials, and you'll kind of see what works and what doesn't work. Write some of your own tutorials as you're learning stuff, right? And develop a GitHub page. People want to hire people that can code, and GitHub will signal that for you very, very conveniently. If you're programming every day and you're pushing up to GitHub, it's going to show a lot of activity. Someone's going to look at that and be like, okay, yeah, they can program. Setting up your LinkedIn. Think of LinkedIn as a recommendation algorithm, just like YouTube, right? They figure out what you click on and they make recommendations along those lines. LinkedIn is also a recommendation engine. It makes recommendations based on the information you give it about your work history, the words you use in that work history, the kind of jobs you're looking for, the kinds of people you click on, what their job roles are, what institutions they're associated with. So you can tailor that, right? You can tailor that very specifically. So when you start looking for a job, which LinkedIn is very helpful at, because part of what the recommendation engine does is recommend jobs to applicants. So if you're very disciplined about tailoring your LinkedIn to a specific role, it's going to be a lot better at recommending roles for you. So you can go through and very, very quickly apply for a lot of stuff. So blogs, your GitHub, LinkedIn, those are some good places to start. And then for your GitHub, it's smart to have projects that show a breadth of experience. So have some kind of regression project on there, have some kind of, categorical, where you're predicting categories, have some kind of clustering project, do something that shows you can kind of work through different problem types. And that'd be a pretty good start for a profile.
Next one is, what programming language is the most valuable?
Honestly, I think knowing more than one language is more valuable than any single one that can be ranked. Right now, it's probably Python, but things change, and they change very quickly. Stuff falls out of favor like that, so you don't want to ever take anything for granted in that regard. But the second, or the hardest language you'll learn is the second one that you learn. But once you get through that, you kind of realize what's similar, what's different, what to pay attention to. All these things are really just descriptions of different aspects of computer science, how to loop through things, how to iterate through things, big O notation, how quickly do things grow, can things scale, recursion, so these are all these kind of like practical concepts of computer science that every program language does these things, dealing with different data types like lists or dictionaries, right? And what you learn when you learn multiple languages is that's pretty much that doesn't change, right? What changes is the syntax that you use to represent that. Just like in Spanish, we have concepts, or we have words to represent concepts like water and dog and sun and all that stuff. And we have those same concepts in English and every other language. We just use different words. So I would say for data science specifically, knowing Python and R is very secure. Become proficient in one and kind of exposed to another, and you'll be in good shape. It's the same thing with SQL languages, right? There's however many, and when you go to apply for jobs, you're going to see like, oh, this employer wants this version of SQL and this employer wants this version of SQL. How am I going to ever get a job unless I go learn 10 different flavors of SQL? You don't do it that way. You just pick a couple that seem to be roughly popular. I highly recommend Postgres because it's free and open source and a really, really great database language. But if you can prove to a hiring manager or a technical recruiter that you can learn 2 SQL languages, they're going to take your word that you can learn a third. And again, all that stuff is very similar. So don't feel overwhelmed by that stuff. I'd say start with Python, start with R, whichever you're more comfortable with, get exposed to the other, learn a couple SQL languages, and you're in good shape.
Okay, we've got, what's the best way to stay in the know with the data industry?
It's kind of hard for me to answer because I work in the industry. So I get a lot of my information from professional relationships and colleagues. I don't know. Well, it might be a little controversial to recommend just due to recent changes in leadership, but Twitter, there was a really strong data science community on Twitter, and a lot of original research, a YouTube channel called 2 Minute Papers, especially if you're more interested in the cutting edge machine learning AI stuff. It tends to be a lot more academic and not so much focused on the industry itself, but in a lot of cases, the academics is ahead of the industry. So, following a channel like 2 Minute Papers would be good, just to get exposure to kind of what the cutting edge is. And, if you've got a subject matter expertise, like let's say you've got a finance background, and you come across something that's cutting edge that you have a finance application for, people make a lot of money that way. So, that would be a good one, but really just Google stuff, just see what stuff is, every year do a top 10 data science algorithms for that year, stay brushed up on those. It's not hard to stay informed, but it's things kind of move around, you just got to look in a lot of different areas.
Okay, we've got, since you've worked in-house and consulted, could you walk through the differences between the two for data projects? I know that business consultants focus on artifacts, but this seems challenging when you're looking at data structure and quality.
I mean, as a general rule of thumb in industry, what makes money is what plays. You know what I mean? Like we're not, most of the projects I've worked on, we're not interested in chasing ever decreasing levels of precision or accuracy. It's just like, the unit of precision for any business endeavor is at minimum a penny, right? So anything that's more precise than that is worthless. And usually, I mean, think of what the rounding error for a dollar amount is for most, medium to large companies, right? They're not going to keep track of hundreds of dollars, thousands. You find something that works well enough that makes money. That's what's going to go, right? Academia is obviously going to be more interested in precision and making sure that things are right and foundationally, well built and all that kind of stuff. But in industry, you're just trying to make money. So you just get to that point and then you're good to go.
Okay, we've got one more.
Yep.
GraphQL seems to be a different creature altogether versus Postgres and other SQL types. Can you contrast it with the others, at least at a high level?
Yeah, and I'll preface this, but I don't know too much about GraphQL. I know a little bit. I know it's basically a NoSQL language, and it's using things like nodes and edges to organize information rather than kind of like rows and columns. And I mean, like anything, there's going to be, it depends on your use case, right? If you have a lot of structured information, then, going with a SQL database is going to be probably the most optimal. But let's say you have a large amount of information that's really kind of unstructured. And, let's say like, you have like hundreds, if you were to try to flatten that into a table, you'd have hundreds of columns. A bunch of it would be null because certain things just don't apply to certain rows and everything like that. Like that can become really, really slow and really sloppy. And so that's where things like NoSQL languages can help out, right? So looking at like document-based query languages or graph-based query languages, they're capable of doing certain things more efficiently than the structure of a SQL database. They're capable of dealing with kind of different kinds of data, messier data, right? So it's probably good to know both, but in my career, in 12 years as an IT professional, 5 years as a data scientist, I haven't really had the pleasure of using GraphQL and I haven't seen it much. But I haven't been everywhere either. So it just kind of depends. But I think to kind of sum up the answer to that question, the importance is knowing how to distinguish the two and getting a good intuition for which tool is most appropriate for the task you're trying to do.
All right, I think we've covered everybody's questions. Any last minute, anything we want to jump in?
Me or we from Remarkable?
I was asking
Power BI or Tableau win.
There you go.
I've been waiting for Microsoft to die for a while now. And as someone who had to manage an enterprise Microsoft environment, I have just so much PTSD from that. So I'm rooting for Tableau, like hard. It's I also like it. I mean, I haven't used Power BI much, but the thing I like about Tableau is it's very platform independent. Microsoft, they want you by the short and curlies. They want to lure you into their playground with Windows and Active Directory and all that stuff. But don't fall for it. Learn Linux and avoid Microsoft.
Thank you, Mark. And thank you everyone for joining us tonight. If you have any further questions about Flatiron School, I did drop the link to schedule a chat with our amazing admissions team. And as a reminder, you will receive a copy of tonight's presentation within 3 business days after the event. If you'd like to see any previous events, you can head to our YouTube channel, which I also dropped in the chat, and subscribe. Thanks again, everyone. And thanks again, Mark.
Thank you.
Have a great night.
Thanks, guys.
Take care.